Hello viewers, so we have a question on the board. The general relation between shear stress and velocity gradient of a fluid can be written as tau is equal to A du over dy to the power of n plus b, where A, b and n are constants that depend upon the type of fluid and condition imposed on the flow. Comment on the value of these constants so that the fluid may behave as an ideal fluid, a Newtonian fluid and a non-Newtonian fluid. So we want to comment on the fluid. How can we make the fluid to behave as an ideal fluid? How can we make the fluid to behave as a Newtonian fluid and as well as what non-Newtonian fluid? So remember, in an ideal fluid, I explained that an ideal fluid is a type of fluid which do not have viscosity. That is, our viscosity is zero. Our viscosity is zero. So the velocity gradient will be given is what? Our A is our constant, which is our viscosity. So our viscosity is our A. So for us to make this one to be viscosity to be zero, that is to make our shear stress to be zero, it means that if our viscosity is zero, our shear stress will be zero. It means for it to behave an ideal fluid, our A will be zero, our B will be zero. Then it's behave an ideal fluid. Our tau is A du over dy into n plus b. So we want to what? We want to find that this behave an ideal fluid. And ideal fluid means our viscosity is what? Is a type of fluid in which the viscosity is zero. And if our viscosity is zero, our shear stress will be zero. So for this one to behave an ideal fluid, our A and B will be zero. If our A is equal to B is equal to zero, so we have to put our A as zero here. We're going to have tau is equal to what? A into du all over dy into n plus b. Our b is what? Zero. So we're going to have tau is equal to what? 0 plus 0. Our tau is what? 0. So for it to behave an ideal fluid, our A and B will be 0. So therefore, A is equal to what? B is equal to 0. So it behave an ideal fluid. An ideal fluid. So let us solve the number 2, a non-Newtonian fluid. For this to behave as a non-Newtonian fluid, and remember, by the definition of a Newtonian fluid, is a type of fluid which obeys the Newton laws of viscosity. That is, it obeys that our tau is equal to mu du all over dy. And let's consider that our tau here is a constant, which is what? Our A. So we have tau is equal to what? A du all over dy. So it means for you to satisfy a Newtonian fluid, this velocity gradient we have been given, it must satisfy this. So it means we have to make this to be in form of this. So for us to make this one to be in form of this, we are going to consider that our tau is equal to what? A du all over dy into n plus b. That our n will be 1 and our b will be 0. N is equal to 1 and b is equal to 0. If you put at n is equal to 1 and b is equal to, what are we going to have? We are going to have a shear stress is equal to A du all over dy into n, which is 1, plus b as what? 0. So we are going to have our tau is equal to A du all over dy into 1 plus 0. So we are going to have tau is equal to A du all over dy. So therefore, it behave non-Newtonian fluid. It behave Newtonian fluid. So it means for this one to satisfy a Newtonian fluid, it must obey the Newton law of viscosity. So it obeys the Newton law of viscosity, where our A is what? At n is equal to 1, our b is equal to 0. So let us consider the last question. Non-Newtonian fluid. For it to satisfy a non-Newtonian fluid, so according to what? Definition of non-Newtonian fluid, it do not obey the Newton law of viscosity. That is, it does not satisfy this equation, this formula For a non-neutrophilic fluid to not satisfy this equation, according to what we are given here, if our N is greater than 1 and our B is equal to 0, our N is less than 1, our B is equal to 0. By using this, if we put this at N is equal to 1, if our N is greater than 1, that is 2, 3, 4, 5, it's going to behave non-Newtonian fluid. If our N is less than 1, this one is going to behave a non-Newtonian fluid because it's not going to satisfy the Newton law of viscosity, which is this. So from here, for this one to behave a non-Newtonian, for this to behave as a non-Newtonian fluid, our N must be greater than 1, where B is equal to 0. Our N must be less than 1, where B is equal to 0. So from this, if our N is greater than 1, we call it a dilatant fluid. And if our N is less than 1, we call it a pseudoplastic fluid. So therefore, it behaves non-Newtonian fluid. So you can see that we have shown that it satisfies an ideal fluid, this one satisfies a Newtonian fluid, and the last question satisfies a non-Newtonian fluid. So this is how to show that a fluid behaves in theory. So this is the solution for it.